Okay, some hopper development, level 3. This is just picking up where we left off from level 2, so that's why we have drawing 4. We got 5, 6, and 7, and 7 is going to be the cardboard mock-up. This one's going to need some trigonometry, and we'll work through this one. These ones here, we'll just kind of give a quick overview with it. Before we start on to this, though, let's review back to level 2 with something just very standard and straightforward here, just with this regular hopper. That's all this one is. Real easy, real simple. This one here just happens to be 4 inches this way, 6 inches tall, and 8 inches this way. Simple as that. How do you go ahead and figure this one out? Well, there was your dimensions there, and our height. All we really have to do is figure out this offset. So there's a 2-inch offset on this, and this is how we're going to find the length of this plate. A lot of people think we need to figure out the length of this seam. Totally not necessary. You do not need to do that. It's just a whole bunch of extra work that is unnecessary. So when you have something on center like this, as we did in level 2, we can do radial line development with it. Really as simple as that. We come up to the apex, we can scribe through. Really as simple as that. We can pick up these points right here. So we can scribe an arc through this point, this point, this point, and this point. And then from there we can just get a chord length and then come off over there with that. So real simple, real easy to do. Or you can do 4 separate pieces. So instead of radial line development, you can just do some real simple Pythagoras like we did in level 2, and then very easily 8, 4, and all you have to do is find the length of this plate. As simple as that. So with this one here, it was just 6 inches, so it's going to be a little bit longer than that. So I just real simply whip this one up. Another thing here too, if we're going to be bending this up, so chances are we'd have 2 seams and just 2 bends there. So it'll be your 2 halves. And this one here, let's just have a quick look. Really see I put a little line here on the inside, and what I did was I just squared off this angle with that line. I'll show you why here. In a press brake, a lot of times what we do is we just take our square and we'll bend it up square. So we'll put our square on the end, and that is where we'll measure to. So versus coming off the machine this way. So if you're using the machine this way, coming perpendicular off, and maybe you're programming your machine, it's not going to be 90. You can see here there's a gap. So how do we go ahead and do that? Very simply, a whole bunch of math that you would probably never go and do, just because it's not worth the time and effort. It's just a lot easier to put your square on the end. But it is hard to eyeball the end of the machine, especially if you got a small piece, so it is a little difficult that way. So the easiest thing to do is I just created this bend set right here. You got 8 and 8, so 8 squared plus 8 squared, square root, get your length across. Simple as that. This one here was 11 and a quarter, I believe that's, yep, about 11 and a quarter I think across, 5 5/8 for that. What you can do is you can measure from here down. So you can, however you can triangulate the length of this one here, either just by measuring the piece or coming square up. So you'd know a distance across the top here, and you could know a distance here at an angle. So then we can just get a distance here. So some real simple trig there just to get the distance of this one here. So we got this one 7 5/8. So if I just laid this out on a piece of paper all the way across, and I just happen to go from the corner to the top corner for this simplicity of this one, and then for this one here, just ended up almost 96 degrees. So if I stick this in the corner down over here, that will square up the top. Simple as that. And that's going to be the same as doing the cones. The cones are going to be exactly the same. We did that in the shop when we were bending the cones. Our radius piece, we always just lined up on the end though. It was just simpler, easier to do. Why would you go ahead and do all this math? Not really worth it. If you had a whole bunch of these to do, or you're trying to set your machine up this way versus measuring to the end, that's probably why. Kind of really as simple as that. But I thought I'd run that through there. Anybody's interested on that sort of offset bend set type stuff there. Besides that though, real simple, easy. This one here only requires one math calculation for that offset, and then you're ready to build this. So obviously the length of this is going to be a little longer than the depth coming down. So coming down this way, so measuring up to here, this plate's going to be a little longer. Okay, okay, there's a refresher from level 2. Let's have a look back into level 3 here. This one here, calculate all the dimensions of the plate, calculate the working bevels. So we've got the working bevels here, 12. Some of the working bevels are already done. And sketch the plates with all the dimensions. The plates you can just sketch exactly as is, except for the dimensions are going to change. So we're seeing a height here, 6'10.5" or 6'1.5" to this bend line here coming down. So obviously that's going to be longer because it's sloping in. So for this one here, you basically just got to figure out all your offsets. There's enough dimensions on here, you can Pythagoras this whole thing. Real simple, easy to do. So instead of one side, we've got a whole bunch. So coming down here, we got plate A. This would be plate A. The length of plate A would be right there, right? Plate C. And then just remember, this would be D. Orthographic coming over. That's on that side, so D has to be here. B has to be here, because that was on the other side of that. Plain and simple as that. Okay, so even working with A here, they already give you an offset, 4'7.5". You got your 6'1.5". Real simple Pythagoras, and away you go from there. Yeah, and I think that was as simple as that. So our working bevels are already done. So this one started off real easy. So obviously 4 different plates with this one, so 4 different lengths. So C over here, we got 2'6" and 6'1.5". Do some Pythagoras on there, and away you go. Don't get too much easier than that. Number 5 here. So it looks like we're missing some working bevels on this one. Anytime you do the working bevel, now we're working in feet and inches here, is the 12 is always going to go on the shorter side. So just as we come back over here, or did I say that right? 12's on the shorter side, 12's on the longer side. Sorry, 12's always on the longer side. Just actually, depending if it's over 45 or under 45, I guess is where I was going with this one. 6'1.5", 4'7.5", 12 always goes on the longest side that's given in that triangular. So similar triangles, right? So the working bevel does have to match the triangle that we're trying to match it to. So 12 always just goes on the longest side. Okay, so whether it's vertical or horizontal will be dictated by how much it's leaning over. Simple as that. Okay, sorry, I got that one mixed up a little bit. So for this one here, we got a 5, so we're going to have to minus a foot off it. So we got 4¼ so 12 would have to go on this side over here, because it always goes on the longest side. From here though, exactly the same. Plate A, flipping down, plate C, then a D would have to be here, and B would have to be here. From there, it's just simple Pythagoras. And to draw the plates, I guess you could put a piece of paper on top and just kind of draw those out and give it a dimension that way. Just to realize when you are creating this, plate D here, so if this is plate D, it would look exactly like this with these offsets. When you create this, the only thing is the dimension here is going to be longer than the 4'1¼ because we got to take the foot off here. So depending if where the bend line is. So there is a bend line on this one, so you can see that there. So for this one here, it is going to be longer, right? So you got to calculate that over here. So whatever this distance is over here will then just become that distance. Besides that, all the offsets are the same all the way through. A lot of people get confused about that. Again, like I said, a lot of people always try to figure out the length of this seam. Totally unnecessary. Remember what I said before? Let's pull this one back. You do not need to calculate the length of that seam. You can, but why would you? You don't have to. If you cut and lay out everything correctly and you do all your offsets correctly, when you put your pieces together, the length will match. And before cutting your pieces out, you're going to double check with your tape measure that they're all going to match together. If something doesn't match, back to the drawing board. You're going to have to find out where or what offset you went, where you went off. So you can always label these plates, and you can always label the plate that's going to be adjoining the plate, and then you can just double check those two seams. No sense doing a whole bunch of extra math calculating that length, not whatsoever. Okay, so just figure out your vertical length there. This one here, there's 6, same sort of thing. We're starting to see the pattern here. Pay attention to the bends that are at the top here. So there is some bends here and here. Actually, I guess that's where those the bend angle. So I guess that's actually where your working bevel can come in as well. So not just here for the working bevel, which would share a similar angle as this one. I guess that would line up to there as well, so that would work the same. So just because this working bevel here, if you're on a bench, you can just pull out your 2-foot square and you can just measure over 1 foot, whatever the other dimension is, scratch a line, and there's your bend set. Simple as that, right? That's why they use the working bevels. Simple as that. So here we got a nice metric one here, nice and easy. They switched up the A, B, C, D for whatever reason. So again, this would have to be A, B is over here. Flipping over here, C's got to be here, and D's over here. So just mix that one up a little bit. So really as simple as that. We've done that before, not too difficult. Number 7 is just a little bit more difficult on this one. That's just because there's just a little bit of trig here with this one. We'll go through and just do a little bit here. So the first thing we're going to have to do is, well, we can start with A, B, C. C is the one we're going to need the trig with. Just because these kick, these two side plates here, B and D, they kick in right here. So there is a vertical height, and then there's an offset length here. So we do need to calculate for that. This one here, we could use Pythagoras and figure out this overall length. That's no problem. But we do need to figure to this bend line here. This is the problem area here. We need to know the distance from here to here. And we also need to know the offset here. So from here to here. And that's just to create these side plates. That's why. That's why we need that dimension, so we'll have to figure that out. So flip this down, and we'll do A. So you can always go ahead and see if you can do this one on your own. So you can always pause the video right now and see if you can do this. Because I'm going to reveal what's underneath this paper right here, and we'll see a full layout of all these plates. Plus we'll see the cutout of all this thing put together as well. So you could pause right now, see if you can go ahead and do this on your own. Cut your pieces together and see if we can build it, because we are going to build this one. This is the one that we're going to cut out, we're going to put together, and we're going to build here. Okay, so back to it here. C is over here, flipping down. D is this one, and B is this one over here. Okay. So for this one here, A, real simple, straightforward. We've got the 162, we've got the 24. We can easily calculate that length. That's a no-brainer. Same with D, 162, 158 offset. We can calculate that. That is a vertical height. No magic math there. B over here, the same thing. We're going to use the 162 and the 102 just to get that distance there. Okay. The hard part here is this one here. We're going to have to figure out this angle or this angle. I'm just going to go with this angle up here. So for this one here, we're going to go the 272, and we got an overall height. So 156, 36, and 162. I wrote down 354 for an overall height, just so we can do some trigonometry here with this one. So we'll go opposite over the adjacent just to get this angle here, and that'll be 37. I did some math on the other page here. We'll pull it back. It's 37 and a bit degrees for that one. And then for that one, or for this offset, the distance from here to here, we can use the 156 plus the 36 here. So 192, just wrote down a dimension there. And this angle just to get this offset. So here's a little bit of math here. I'm just going to pull in a little bit of math with this one. Everything I ran through, play A, B, and D, real straightforward. The dimensions are all Pythagoras with this one. This one over here, there's the 272 and the 354. So 37.53729. Real important with that one. The 192 and this angle, tangent, we get a 147. This is the important number right here, 147.5. The distance from there to there. Now what's the distance from there to there? Super important, we need that one. What is that distance? So that distance there, we got 296 minus the 147.5. 148.5. Now that's the distance from there to there. Don't forget about the 24 mil, that's at the end over here. When we start to lay this out, we're going to have to lay this out with adding 24 mil onto that to get that overall. And then we can get our height from there. So from there, we've got those offsets, super important. There's our offset there. And then we can just get our top length here. So this one here, we just use the cosine of the 192 here. So this one here is 242, and that's to this little dot right here to the top. And to calculate the bottom there, we're going to use the 162 here, and we'll cosine the angle just to get the adjacent side. And we're going to have a 204 down here. These are kind of the important dimensions here. There. Okay, so those are really super important to lay out plate C. That's kind of the harder one, but this plate D and B are a little difficult as well. When we are laying out plate B and D, we're going to use all these offsets, these two here, but the 162, that's where that changes. So D over here, D is going to be 226, so 226. 226 here for the length, and again that length is square, it's not measured on the seam. B over here is 191. And A is 164. Okay. Let's go ahead and reveal what this will look like. Obviously did a whole bunch of work here to save a whole bunch of time. So it does all fit on one piece of paper. The 22-inch full-size craft paper here does fit on there. Now this one over here, let me just get this white page out of the way here. Anytime you're laying out, square up your sheet, you can always use your T-square. That's what I did for this one, pretty straightforward. Another thing you could do is you can just use your 2-foot square, and that's going to work just as well. There's nothing wrong with that. You can square off your sheet and work from that way. I do recommend using the corner of your sheet or the edge of your page. There's no sense coming in an inch and having to cut off. There's no reason for that whatsoever. So I started with my corner up here. I started with my biggest piece and squarest piece, and I started over here. So we had a 302. Let's go back to our page here. 302. So that's the first thing we want is a line, 302. We're coming down how far? 242. There's our 242 there. And then we're coming down again. How far? 204. Now I laid this off so it looks like this. So I've got the 102 offset on this side and 158 on this side. Simple as that. There's plate C. Okay, no big deal. Plate A, real simple. I fit it in down here. Plate D though and B, these are a little harder ones. They do fit on the page. I do recommend. I started in this squarest, well, actually it doesn't really matter. You can do either or, but let's start with maybe B here. And I actually just worked off this corner here. May as well try to find something square, something to work off, something to go one way. So for this one here, you do need the 296 plus the 24, right? So you need 320 from here to here. Overall, it'll be 320, because you got to go 296 plus the 24. So a lot of times when you're laying out, create yourself a box and lay out within that box. As simple as that. So there's your top corner, there's your bottom corner. Come over 320 and down how far to find that. Well, how far do we come down? 156 to this corner. And we're in 24 for that corner. We come down 36 to here, we're still that 24 in. So there's that 320 line, there's that 296 line. There's your 2. There's that corner, there's that one there. Now you already found that bend line. Since the bend line's done, you already know to come over 148.5, because we wrote that here. Come over to here, make a dot, up to your corner. There, top's done. Simple as that. The length here, plate B, 191. So we need to come down 191, and then from this that we've already located out here, from this edge here, we're going to come out the 48 here as well. So we've got this line down here, 191, make a mark. We've already got this corner, and then from this one here, we're going to connect to here. Now with this one here, just remember, this is not a straight line. When we go to bend this, it will then become straight with the plate. So as we bend this up, this elevation of 191 is going to shorten to the 162. This is plate B over here. See, that's what happens there with that. Those are just playing with angles there. That's all we're doing. That will straighten out when that bends up, because this height here will become over here. Simple as that. There's plate B. Plate D, come off the other corner over here. That's what I would do. 320, over you go, just as you've done already on this plate, and then we're coming down. That's why we kind of have the double lines over here coming through. Kind of had to lay over top of one. I was out of room, but we still have plate to work with. 320, we're still coming down the same. Bend lines line up, because it's the same on top. It's the same either side. It's just the bottom length that's a little bit longer. So all this is still the same. So 296, 24 off, come down. The 156, and then the 36 to there. And then we've got the 226. The 226 here on the slope. We're coming down 226 to the bottom, and we're on this corner, so we're coming out 48. 48's right here. Right? There's the side plate, there's the 48. That's why the 42 over there was for the 42 over here. So 42 coming over. Did we find this location yet? If not, we know where this location is, so we come over the 148.5. Simple as that. We come to there, connect the dots, and up you go. Plate D is done. Simple as that. Again, this is going to look a little more extreme of a bend on this one, because it's got more travel to it. So as that one bends up, it'll flatten out. Simple as that. Okay, plate A here. This is the smaller one at the front. This one here, I just took the longest edge and put it on the longest edge. There's less cutting. I didn't want to flip it upside down, because then I'd only have this over here. So I'm going to flip it upside down, put it between my pieces so they fit. I know how wide this is. It's 302. I know how tall it is. I know it's going to fit between my pieces. So let's just nestle it in here. Could we have nested this together better? Yeah, sure we could have. But hey, it all fits on one sheet, so pretty happy with that. This one over here, I could have flipped around the other way. Could have tried to save some room if this was really expensive alloy plate or something like that. I'm going to nest these a lot tighter together, but for this exercise, it's just paper. Fits on the page. A over here. Here we go. We got the 36. Coming down 36 right there. 164 to here. There's your offsets. 102, 158. There's your 164, as simple as that, okay? This 162 here is a vertical height, right? Don't get that confused with your offsets coming in, okay? When this one here gets bent up, and it's got to bend quite a bit. Look at the bend on this one. When it gets bent up, it'll be 162 vertical height from there, okay? Go ahead, cut those out. When those are all cut out, it's going to look like this. Now, mark your plates inside, outside. This was an outside, inside, outside. Arching inside for that one. I already went ahead and cut some out here. Plate C, plate D, and A. So you can obviously tell this is my longer side on this one. So this is going to be this one here. This is my outside, so I need to flip it over. So I just lost that line there. These are nice when you do have the bend down because you can just put them on the edge of your table and you can just fold them in that way. So real simple. So this one over here, we'll just give it a little bit of bend. There we go. That lines up there. That lines up there. You don't have to do anything more to it than that. Real simple. This one here. Always nice just to overbend it just a little bit more. And it just fits right in there just like that. This one over here has got the bend in it as well. That's an inside. That fits right on there just like that. All those line up just perfectly there. Okay, so we can't really get too much harder than this. We're offset in both directions and we've got a sloping top. So even if we had a sloping bottom, we'd probably rotate this thing so something was flat somewhere, right? Or not, depending on the complexity or how easily you can rotate the drawing. So really it's kind of as simple as that. Okay, go ahead, tape those together, make it a hopper, and that's your assignment. Take a picture, and that's it. That is the assignment. That's the hopper from there. So here's your layout. It's going to take you a little bit of time, maybe to do all that, maybe an hour or something like that. Cut it all out and tape it all together, and that basically gets your number 7 there. Okay. There's your hopper. There's your review into level 2. From level 2, just coming into level 3 here. So no much more difficult than that, besides just a little trig here and there where need be. And once again, just a reminder, we don't need to calculate the length of that seam. Okay, that's something that we just never have to do. So same with the bend set there, right? Just remember with the bend set, a lot of times it is easier just to bend it up at the end, so it's 90 degrees, as simple as that. So okay, good luck.